Right, here we go. Session 19, matrix transformations, the second session on matrices. Let's get cracking. Right, okay, so matrix transformations. This is one of the applications of matrices and one of the uses of them in real applications. And I think it's good to maybe go straight in with an example question. So, e.g., work out the image point of for the matrix transformation. 2, 3. This could be worded in a number of ways. It could be, say, by the matrix given as that. Could be, say, work out the image point of -2, 5 given by the matrix that. So what this means is we're starting with a point on an axis, and our original point is -2, 5, somewhere up here. And if we multiply that point by this matrix, it is going to push it or move it somewhere else. And this sort of thing is used a lot in computing when you want to move a point to another point. A lot of things like computer gaming uses this. If you want to move one image or one image to another area, you would need to multiply it by a matrix, and it can be done very quickly. So it's used a lot in computing. So how do we do that? So we literally just multiply that coordinate by the matrix. So now you've got to get the order matters. So the order matters. So you put the matrix first, the transformation matrix first. So transformation matrix first. So 2, 3. -2, 1, and then you multiply it by the coordinates, and you write these as a column coordinate. So you multiply it like that, and this is going to give me a bit of a recap on multiplication. So 2 times -2, sorry, plus 3 times 5, and then on the bottom you've got -2 plus 1 times 5. And that gives you a coordinates of that's -4, add 15, 11, 4, add 5, 9. So your answer, your image point, will be 11, 9. So that coordinate there, if I multiply it by that matrix, it's going to move it to 11, 9, somewhere up there. Okay, so that's my original point, and this is my image. So it moves it from there to there quite quickly. A computer can do that very easily, and it can do it for many coordinates, a whole shape, for example. Okay, so let's look at it sort of working backwards, more of a sort of exam style question. So e.g. 2 under the matrix 2, 3, 1, 5, the image of coordinate D is at the point 20, 31. Find the coordinates of D. Okay, so under that matrix, it tells us what the image is this time. It tells us where the coordinates is going. So again, if we had a quick axis here, 20, 31, let's put it up there somewhere. That is the image of D, D dash. That's the image of D. We're trying to work out where D is before it moved to that location. We're trying to sort of go back in time. Right, so I set this up as normal. So I start off with my matrix. Now I don't know my coordinates of D, so I'm going to put them as X, Y. But I do know my image point, which is 20, 31. And then I do this like I solve this. I multiply out the equation on the left, multiply out the matrices on the left, and equate it to the right. So it's going to be, if I do the left here, 2 times x, 2x, plus 3 times y. That's the top. that'll be the top one. The bottom one is just 1 times x, which is x, 5 times y, 5y. And that's going to equal 20, 31. And I just can equate the top now. I can equate 2x plus 3y must equal 20, and x plus 5y must equal 31. And I've got a set of simultaneous equations that I can solve. If I times that equation by 2, I get 2x plus 10y, 62. And then if I do sort of 1, if I do 3 minus 1, do elimination here, I get 7y equals 42. My y coordinate is going to be 6. And if I substitute that back into one of the equations, I think I get 2x equals 2. My x coordinate is going to be 1. So my answer, point D, if I went back in time, it is 1, 6. That's where it started. So I started over here, 1, 6. That was my coordinate D. I times it by the matrix and it moved that point over there. Okay. Right, now there is one matrix, there is a special matrix. Called the identity matrix, which does not transform the points at all. Okay, so there's one matrix, if you multiplied it by a set of coordinates, it would just stay where it is. It wouldn't move it at all. And you might want to pause the video and have a think about what that matrix would be. But the matrix, the identity matrix, is in fact 1, 0, 0, 1. Okay, this is what we call the identity matrix, 1, 0, 0, 1. And you can show this quite easily because 1, 0, 0, 1, if it was a transformation matrix, and I multiply it by any coordinate, so x, y, my solution to that is going to be 1 times x plus 0, 0 times y, and then 0 times x, 0. So I get the same coordinate. My image equals my original, and therefore no transformation. Now this is quite a special matrix. There's a few uses of that, which we'll see in the next video. But that is just for now. You need to know that that is the identity matrix. Okay, that is the learning for today. I want you to do a few questions on this now. So it's page 243, and it goes over on to page 244. It's exercise 9b, and I just want you to do the evens, please. So question 2 to 12 inclusive, okay? And tune in next time. Next video will be the last one on matrices, sadly. But I hope to see you for session 20 then. Thank you very much. Well done.